Hey, hello guys. Now we are just going to see the next theorem because in the previous we just discussed a lot of good theorems. So now we will be discussing the other theorem, especially last time what we had just discussed, the Maclaurin's method. So in Maclaurin's method, the x minus 1 like that it should be, and suppose 10 x minus 1 means you should not multiply 10 within inside, okay? X minus 1 it should be as it is. Whenever the x minus 1 comes negative, you should remove the thing, okay? Whenever the x minus 1 comes positive, we need to include the thing, okay? I think so you can understand. So now we will be seeing the Castigliano's theorem, okay? You can see this is very important method, and it's so simple method, okay? Why I'm just saying it because we can just calculate easily based upon this method, okay? So Castigliano's theorem. So Castigliano's theorem, okay? So in this, especially the total energy we need to resolve, okay? So especially total strain energy, okay? So suppose how much we are applying the load, based upon the load there will be a certain amount of energy that's been stored, okay? When the total strain energy U equal to U of P1 P2 of a moment, okay? So if you apply the load means it means like this, you are applying P load means certain kind of energy will be stored in this beam, okay? Based upon that we are just going to calculate, wow, you can see based upon energy we are just going to calculate the deflection as well as the theta, and whenever we just apply the moments like this, based upon the moment also we are just going to calculate the energy, okay? I think you can understand. So what the main thing is, strain energy is, okay, this one. So it means according to load applied we are just calculating the deflection based upon U strain energy, okay? So deflection 1 equal to dou U upon dou P, okay? So you can see how we are just calculating the differentiation, how we are just calculating the deflection 1 in strain energy, and according to how much strain, it means how much strain energy, for example how to I need to say means so you can see in the differential equation the top one will be the entirely dependent variable and the bottom one will be the independent variable, okay? So you can see the strain energy is entirely dependent on the P, okay? You can see this P leads to the storage of strain energy, so dou U by dou P, okay? So this U variable is totally dependent on the P variable, okay? This P is independent variable, it doesn't depend. So you can see if like this moment is given means strain means total deflection is equal to dou U by dou M, okay? This strain energy is completely stored on, it means depends on this here, okay? I think so you got the point. So this one will be theta moment, okay? I think so you can understand. So this thing entirely P1 P2 and this thing entirely, okay? So how we can find the strain energy? U equal to how much? So as I just told, this one P, this one deflection, this one is U equal to 1 by 2 P into theta, okay? So deflection equal to PL by A times of V, okay? 1 by 2 P PL divided by A times of V, 1 by 2 P square L divided by A times of V into A into A. So you can see 1 by 2 P square by A square, this one area into length is volume divided by E, okay? So you can see strain energy divided by volume equal to sigma square divided by 2 times of V, okay? Just a simple calculation, I think you can understand. Sigma square 2 times of V, okay? This one is P square, this one 1 by 2 P square L divided by A times of V, okay? I think so you can understand. So the bending moment is being like this, bending moment M. So U equal to same M square L divided by 2 times of E times of I, okay? I, okay? Bending moment, this one I, okay? I think so you got the point. So same thing here, it will be M, here it will be theta, okay? So 1 by 2 M of theta, okay? So next thing, suppose if you want just take P square L by 2 times of AE if mostly will let 0 to L P square D of x, okay? This L is represent D of x divided by 2 times of A times of V, okay? Moment also it means for the moment 0 to L P square is M square D of theta, okay? D of theta, D of x, okay? 2 times of E of I. Okay, just a simple thing, right? Because while the problem I just tell, I can understand easily. So if any kind of torque is given like this, torque is given T, okay, so same T theta, so E equal to 1 by 2 torque into theta. Okay, so what is the value of theta? So theta equal to TL divided by GJ. Okay, and it will be there's a one formula equal G divided by I'll just tell you. Okay, this is just a formula, just remember. I'll just tell you. So put here equal to T square L by 2 times of GT. Okay, I think you are getting the point. So how we can calculate the strain energy? You can see for each and everything we need the moment. Okay, you can see this one is moment. Okay, I think you got the point. So mx square dfx divided by 2 times of I. Okay, do not get confused. Okay, so I think you got the point. So you can see what is the total strain energy for this. So mx is minus p of x. So put here and put a square and I think so you can so x cube divided by 3 L. So total strain energy is this one. Okay, U equal to p square L cube, this is U. Okay, we just got the total strain energy as p square L cube 6 EI for which equation we got. For this equation we just got. Okay, so how we can calculate the strain? It means deflection dou U by dou P. Okay, differentiate with respect to dou P. So you can see 2p L cube divided by 6 of EA. Okay, you can see P L cube divided by 3 times of EA. Wow, we just got the thing. Okay, if theta is dou U upon which one? Dou M. Okay, there setting this one we just got it. Okay, for the moment I'll just explain because this one little bit of explanation is there. Okay, but anyways we can just calculate based upon this also. Okay, so you can see suppose theta equal to dou by dou M moment. Okay, moment means you can see where is the moment, this one. Directly instead of taking the equation directly we can just take moment is minus p of x. So it means you can see here differentiation, here integration will be a little bit confusing one. Okay, so I'll just explain you later on because we need to expand first of all. It means instead of having this, I think so you can understand. So if you just put means here differentiation will be, here integration will be. So only one to be either differentiation or either integration will be. Okay, I think so you got the point. So next one you can see about this one. So you can see simply supported beam they just given P. Okay, we know that deflection equal to P L cube will be 48 EI. Okay, suppose this is deflection will dou U by dou P. Dou P L cube will be 48 of E. So dou U P L cube will be 48 of E dP. Okay, integrate. So what will come? P square L cube divided by 96 of E. So this is the strain energy. Okay, I think so I got the point. So next one, as I just told you before, the integration differentiation, it should be only one thing. Okay, so we'll see. So U equal to what? Integration of m x square of dx divided by 2 times of E I of I. Okay, deflection is dou U by dou P. Okay, put here dou by dou P. This entire U won't put here. So integration of m of x cube d of x divided by 2 times of v of a. Okay, suppose if we just integrate it, wait, I'll just explain you a little bit. So you can see dou u by dou p is there. Okay, so we are just differentiating with m of x with respect to dou p. Okay, so integration of 2 m of x dou m by dou p of d of x. Okay, divided by 2 times of e. Okay, e cancel. So total deflection equal to integration of m of x dou m by dou p d of x dou p e times of a. Okay, this is the equation. I think so you can understand. So next one, theta means dou u by dou m. Okay, so now we are just going to differentiate. Okay, so dou by dou m integral of m of x square d of x with respect to 2 times of d of a. Okay, so integration 2 times of m of x dou m by dou m with respect to d of x divided by 2 times of e of a. Okay, I think so you can understand. Okay, this one is a particular moment of x. Okay, so 2 gets cancelled, so theta will be integration of m of x dou m of x divided by dou m of d of x divided by e times of a. Okay, so next one, so you can see here it means definitely the deflection occur. Okay, so because you can see guys here they haven't given any kind of p load, so calculus deflection is dou u by dou p. Okay, so we need to calculate the p means put indirectly p tends to 0. Okay, it means just an imagination. So this entire thing back downward means so w into times of l. Okay, w dl will be definitely the p. Okay, w dl means it will act at center. Generally the what will be the shear force will be like this. Okay, minus. How we can just write just think it of, so imaginarily we applying the point load. Okay, so you can see p tends to so much smaller. Okay, 0.001. Okay, so deflection occurs notice it. Okay, so as I just told about deflection, dou u by of dou p equal to integration of m of x dou m of x divided by dou p of d of x will be e times of a. Okay, what is m of x? So p times of x, next one, left minus w times of x and x by 2. Okay, so minus p of x minus w x square divided by 2. Okay, just go and substitute here. This is m of x minus p of x minus w x square divided by 2. This one will just calculate means dou by dou p. This one will come. I think so you can understand. So you can see with this is with dou m of x of dou p. Okay, with respect to this one you are calculating, here will come minus of x. Okay, of d of x divided by e times of x. So since here we just consider the p tends to 0, this will be cancelled. Okay, so w ei 2, this one is minus, so minus x cube of dx minus w x power 4 divided by 4 will come 8 of ei. So deflection is this. Okay, it comes minus means it will just go downwards. Suppose the same thing goes for the moment also. If moment tends to 0, how it will be? Moment is 0.001 and moment of x is minus m minus of w x square divided by 2. Okay, so dou m of x of dou m equal to this one minus of 1. So theta equal to integration of m of x dou m of x by dou m d of x divided by ei. Okay, m of x is minus m minus w x square divided by 2 minus of 1 of dx. Okay, divided by e times of I integration. This will be gets cancelled. So minus and minus plus w x square divided by 2 times of d of x divided by w x cube divided by 6 of e. Okay, sorry, L cube. Okay, I think so I got the point. So we can just see the next one. So you can see जिस पॉइंट में डिफ्लेक्शन निकालना है, अगर उस पॉइंट में पॉइंट लोड हो तो हम एक विचुअल पॉइंट लोड फ्रिक्शियस पॉइंट लोड विल अप्लाई and we'll just after differentiation we'll make the limit. Okay, suppose if p and m not given, make imaginary p and m. Okay, and after making imaginary p and m, just after differentiating it, remove. Okay, so next thing we can just see about this question. It's been asked in IELTS. Okay, question is so simple. This one is here, this one is also here, I 2 times of inertia. Okay, so when Castigliano's theorem we need to apply whenever ei varies. Okay, you can see I is given, so ei varies, we apply Castigliano's theorem. Okay, or uneven shape of beam. Okay, so you can see here I varies and ei also varies. Okay, so this way we need to apply. So just make like this. And for example, if I am applying the load here, so you can see we need to find the strain energy. Okay, so you can see for example load is applying here, just a simple guys. Here you can see here when you are applying the load, the strain energy will be more. Okay, because it will just bend so much. But whenever you apply the strain, this one, for example, if the P is 10 Newton and the energy storage will be same for the both, but you can see the deflection for this will be more, the deflection for this will be lesser. Okay, and because it has 2 times of inertia, it is only 1 times of inertia. So holding capacity is lesser for this one, holding capacity is more for this one. Okay, so since it's been given, you can see moment. Okay, this one is entirely is 2L. Okay, so we are just going to do division 0 to this one. 0 means L and here L to 2L. Okay, I think I got the point. So this is 0 to L. So P. Okay, first that's the term dou u by dou p. This one you need to find. Okay, since it's given, next one will be m of x dou m of x of dou p of d of x divided by 2 times of ei. Okay, ei. Okay, plus L to 2L m of x dou m by dou p d of x divided by e 2i. Okay, since m of x is so 0 to L. Okay, p x x. So next the same thing, L to 2L. Okay, p x x. Okay, m of x is minus p of x. So this also m of x is minus p of x. So put here minus m of x doing minus p of x. This one will be x of d of x divided by e times of I plus L to 2L. This one also minus p of x d of x divided by e times of 2a. Okay, so later you just integrate and we will get definitely we will get the answer. Okay, so deflection will be 3 divided by 2 p L cube divided by ea. Okay, this is the answer. So they just asked about the stiffness, how much the stiffness will be. So force equal to stiffness into deflection. Okay, so I think I hope you understood. So force or load you can just do. Okay, load that will be given in the question. Okay, so we can just make sure this one changing. So P divided by S equal to, you can see P divided by S equal to Q. So 2 times of VA divided by 3 times of LQ. Okay, just put the answer and we'll get the stiffness. Okay, that's it. See, such a good question. Okay, so we'll be going for the next question. It's been asked in 2008. Okay, just 1 second. Okay, so next question will be 2EI, this one EI, this one is a moment and this one also moment. Okay, 2 moment has been given. So next thing you can see this moment is given. So what they have just asked, yes, they have asked us to calculate the deflection. What is the total deflection? So deflection equal to dou u by dou p. Okay, but here p is not there, so apply, it means p tends to 0. Okay, so moment of x is just this one is 0 L to L. Okay, moment of x is about this one 0 to L, p times of x, sorry, p times of minus p of x 0 to L minus px plus of m. Okay, m is in the upward direction, m. Okay, oh, such a good question, guys, literally we'll just tell you. So next one, moment of x L to 2L. Okay, oh, entire thing is given the 0 to L, so this L by 2, this is L. Okay, this is L by 2, this is L by 2 to L. Okay, equal to again minus p of x plus of, see, this is the most important thing here, the moment will be twice. Okay, plus of 2 times of m. Okay, this is the most important. You can see the moment goes to similarly in the both of the way. Okay, see why I am just telling, because you can see, guys, p is there. Okay, and p is there. Okay, here p is there. Okay, so you can see this p acts most of this area. Okay, and while you are just considering the next one, it means while you are considering this, it means for this one we consider the p like this. Okay, the same one for this bulk thing we have to consider this p and as well as this p. Okay, this p will be the p of L. Okay, this p will be the p of x. So for this one, moment of x equal to p of L minus p of x. Okay, so the same equation goes here. Okay, I think so you can understand. Moment of x is minus p of x plus of 2 times of m. Okay, so deflection equal to dou u by dou p and 0 to L by 2 m of x dou m of x by dou p of d of x plus e of I plus L by 2 of L m of x dou m of x by dou p of dx by dA. Okay, moment of x is 0 to L by 2 minus p of x plus of m. So this one dou u by dou p is minus of x of dx divided by e of I plus L by 2 L. Moment of x is minus px plus of 2 times of m dou p minus of x of dx. Okay, divided by e of I. So this will be 0, this will be 0. Okay, now you just calculate, we will get the answer. Okay, I think so you can understand. See, mostly questions are only being asked. Okay, so see, questions are not a bigger problem, guys. Literally, it's a questions are easier thing only. So you can just go directly. So why? Because since lot of questions is been asked, so we'll just complete the questions later on. So So you can see this one, this one, next conjugate B. Okay. So about this one you can just see load. Okay. So you can see it is structure. It is structure, not a beam. So suppose if deflection occurs, means definitely the tilting will be like this. Okay. So you can see here it's been moved horizontal as well as vertical. Okay. But our strength of materials only tells for only vertical direction. Okay. And as well as the Castigliano theorem tells for vertical direction only, not horizontal. Okay, I think so you can understand. So horizontal is not valid for Castigliano theorem. Okay, you need to understand this one. So okay, force जितना है, force को direction जितना है उल्टा deflection निकाल के something. Okay, I'm sorry, I'm not very much good in the Hindi. Okay. So you can see load is in vertical direction, use Castigliano. Load is horizontal direction, we can't use Castigliano theorem. So we need to just divide. It means we need to just add a certain kind of things. Okay. Suppose for example I am just telling like this, load is been applied, so it's been inclined like this. Okay. How we can just find? You can see like this. So vertical direction, suppose it's been here vertical but here horizontal. So I am just dividing like this. Okay, so you can see load is applying here, and you can see here that definite tilt will be. So I am just changing the entire thing to like this. Okay, now you can see this P into X is, it will just rotate. So I am just turning P into X. Wow, I just turned the two condition into one condition like this plus of like this. Okay, so this thing is this. Okay, this thing is this. So this I am just turning like this. P of X moment. I think so. I hope so you understood. So now you can apply the Castigliano theorem. You can just find it. Okay. Just a simple thing. No need to confuse yourself. Okay. So you can see this one. The same thing that has been asked is P. This is A. This is H. Okay. So divide. So one thing is P. This one is A. Next one is sorry. This one is H, this one is P of A. Okay. Now we just calculate the strain energy. It means this one strain energy A, this one strain energy B. So total strain energy is equal to U times of A plus of U times of B. Okay. So what is the strain energy? So deflection is dou U by dou P. Okay. So U is inverse of 0 to A for the first one. For the A I am just 0 to A M of X minus P of X, dou M by dou P will be minus of X of D of X divided by EI. Okay. Okay. Guys, are we doing any kind of mistakes here? I hope so we are not doing any kind of mistakes. But here it's been little bit ulta ulta. Just recheck it. Dx okay, EA okay. So okay, let us try. So here definitely 0 to A, E x square divided by A will come of dx over P A cube divided by P times of EA. Okay, but anyways, definitely answer will come. Why the answer is not coming, I literally am not aware of it. Okay, anyways, this is a deflection for A. Next one, deflection for B is deflection for B. How we can calculate? This is a moment is given. So this moment means apply B tends to 0, 0. Okay, what is the moment of B? Minus P of x plus of P of A. So dou m of x of dou P will be minus x plus of A. M of x minus P of x plus P of A minus x plus of A of dx. Okay, so divided by E of I 0 to h. It is SOM. Oh, here two. Okay. This way I can understand, guys. Here two variables are coming. So suppose minus P of x cube x square plus P of A minus this one will be minus P of A x. This one minus P of A x plus P of A square of dx. E of A. Okay. You can see this will be minus P x square plus minus 2 times of P A of x plus P A square of dx. E of I. Okay. Minus P x cube divided by 3 plus 2P of minus 2P of A x square divided by 2 minus P A square of x 0 to h. dA will write out h cube divided by 3 minus P A h square minus P A square of h here by E times of I. Okay.